Welcome back to VoxStar, everyone. So glad you're joining us for this explainer. Have you ever wondered what happens when our massive, sprawling cities start getting old and cracking? Well, you are in the right place, because today we're going under the hood to explore an absolutely amazing, almost magical mystery happening right inside the concrete jungle. We're going to see how scientists are actually teaching gigantic, towering buildings to heal themselves exactly like humans do.
Okay, picture this. You're riding your bike, you hit a nasty bump, you wipe out, and you scrape your knee. Ouch, right? It stings, you wash it, maybe slap a Band-Aid on it, but eventually, your skin just naturally grows right back. It's basically an automatic fix because your body knows exactly how to put itself back together. Now, hold that thought and imagine a towering 100-story concrete skyscraper. This thing weighs millions of pounds, but suddenly a creeping, dangerous crack starts forming up the side. What if that massive skyscraper could fix its giant crack just as easily and instantly as your body heals that scraped knee? I know, it sounds like pure science fiction, or maybe something out of a superhero comic book, but it is completely real and it's happening right now.
Section 1. Concrete's big weakness. The problem with the world's favorite material.
All right, let's dive right into this. To really understand how buildings can heal, we first have to look at the massive problem with the world's favorite building material, concrete. It's the most used man-made material on Earth. We use it for literally everything: the sidewalks, the massive bridges, the giant skyscrapers. But despite being so incredibly heavy and strong, concrete has one very big weakness: it cracks. Now, a tiny crack might not look like a big deal, but it's actually the start of a wildly destructive chain reaction. Step 1, the concrete gets a microscopic crack from pressure or just old age. Step 2, rainwater inevitably seeps into those tiny openings. And step 3, that is where the real danger happens. When winter hits, the temperature drops and that trapped water freezes. Now here's a very cool bit of science. When water freezes into ice, it expands. It acts like millions of tiny little crowbars inside the concrete, physically pushing the walls of the crack apart and making it much, much bigger. Finally, step 4. After years of this freezing and expanding cycle, the whole structure becomes weak and totally unsafe. So what starts as a gap too small to even see turns into a massive, dangerous problem.
So how do we fix this today? Well, it takes humans with huge, earth-shaking, noisy machines. Think about how annoying construction is. We have to completely block off busy highways, causing massive traffic jams. We have to send workers up on dizzying scaffolds with loud jackhammers to bust out the bad concrete, and then pour gallons of brand new concrete to patch it up. It creates pollution, it's messy, and it's a slow, frustrating hassle that costs cities around the globe billions of dollars. There just had to be a smarter way to maintain the places we live, right?
Section 2. The Sleeping Beauty Bacteria. Meet the microscopic hero.
And that brings us to the astonishing biological mystery scientists uncovered to solve this huge problem. They actually found a secret ingredient hidden in nature. It's an incredibly tough type of bacteria called Bacillus. In the science world, these are known as extremophiles, basically living things that can survive in crazy, absolutely impossible conditions where most other life forms would instantly perish. You can think of this bacteria as a microscopic sleeping beauty. These incredible little organisms can be placed inside tiny capsules and literally put into a state of suspended animation. They go entirely to sleep. And get this, they can stay asleep for up to 200 years. They don't need a single drop of water, they don't need a crumb of food, they just power down and wait patiently inside their microscopic pods.
So the big question is, how do we actually get these microscopic heroes into our buildings and bridges? Well, clever engineers take millions of these tiny capsules filled with the sleeping bacteria and mix them directly into the wet concrete at the construction site. And think about how violent that is. A cement mixer is like a brutal, churning tornado of rocks, but these capsules are perfectly engineered to survive that mixing process without breaking. So right when a brand new structure is being built, these capsules get completely buried deep inside the massive thick walls, cast into the absolute dark, quietly waiting for decades.
Section 3. How buildings fix themselves, the under-the-hood mechanics.
Okay, let's really go under the hood now and reveal exactly what happens when our microscopic hero is called into action. It's a magical 4-step process. Step 1. Say 20 or 30 years go by, a crack finally forms, and that immense pressure rips those tiny hidden capsules wide open. Step 2 is where the irony kicks in. Remember how rainwater used to be the enemy? Well, not anymore. Now, rainwater and air seep into the crack, and instead of destroying the building, the water acts like a biological alarm clock. The water touches the dormant bacillus and instantly wakes them up. Our sleeping beauties are officially awake, and boy are they hungry. Step 3.
The bacteria start chowing down on a special starch food that engineers smartly mixed into the concrete right next to them. And as they eat and digest this food, they produce something completely amazing: limestone. Step 4. This limestone totally fills up the gap, weaving together and sealing the crack entirely from the inside out.
As the brilliant researchers who developed this put it, limestone acts like a natural glue that fills the crack from the inside out. It's like the bacteria are a microscopic construction crew, squeezing out a natural super glue. But here's the thing, this isn't normal glue. Limestone is literal, solid rock. They are essentially 3D printing raw rock directly inside the crack to bind the broken pieces back together. It hardens, cures, and makes the concrete just as flawlessly strong as the day it was poured, totally stopping any water from ever getting deeper inside.
But wait, here is the absolute coolest, most mind-blowing part of this entire explainer. Once the crack is totally sealed up with fresh rock and the water is completely blocked out, the bacteria run out of water. So what do? They just go right back to sleep. Yep, job's done. They return to their dormant, suspended animation state inside the concrete. And because they go back to sleep, this building can heal itself over and over and over again for generations. They are ready to wake up again if a brand new crack appears 10, 50, or even 100 years later, all without a single human construction worker ever lifting a hammer.
Section 4. A building's immune system, the future of cities. Let's bring all these awesome ideas together. Think about the real-world impact this microscopic process is going to have on our cities. It's exactly like giving a massive building its very own immune system. Just like the white blood cells in your body rush to a nasty cut to heal it and keep you healthy, these sleeping bacteria rush to heal the concrete. We are literally turning dead, gray, boring buildings into active, living, self-healing structures. Imagine an entire city skyline where the towers are quietly, secretly taking care of themselves. No more giant, earth-shaking machines, no more crazy expensive road closures, just billions of microscopic heroes doing the heavy lifting from the inside out.
Which leaves us with this final, amazing question to think about. If we can actually teach concrete to heal itself using biology, what other incredible human superpowers could we give to the buildings right outside your window? Could we teach a skyscraper to breathe and clean the smog out of the air? Could we teach a bridge to change color if it gets too hot in the summer? Take a pause and really think about that. I want you to look at the built environment around you today with total wonder and a whole lot of curiosity. Because who knows what other amazing biological secrets might be hiding under the hood of tomorrow's cities. Thanks for joining me on this explainer. Keep exploring and stay curious.